Hello and welcome. In this tutorial, we are going to solve problem number 34 of LeetCode, that is find first and last position of element in a sorted array. So we have given in sorted array and we have to find the target, that is 8. So we can say that this target is present at 2 position and we have to return all first and last position. Let's say we have another 8. So we have to return this occurrence of the first position and the last position. So let's say we have given 3 for this input, 3 4, that means no, 8 is present at index 3 and at beginning, and 8 is present at index 4 at last. So let's say there is another 8, so we have to in this case return 3 5, because 8 is present at third position at the first time and at fifth position at last time. Okay, similarly for index 6 we can see that there is no such element present in this array, so in this case we have to return -1 and -1. So we can see that we have given an array in sorted form. So this is, we can get idea that this problem is something of a binary search. Okay, but how you can solve this problem? One and first brute force approach will be going to apply linear search. So we have to apply linear search from index 0 to index n-1, and we have to keep checking whether current index is equal to target. So if we found out that current index is going to be equal to target, in that case we have to update our starting index, and again we have to keep checking, and if we found that our current index is again equal to target, then we have to update our last index until unless we found another element. Okay, so we have in you doing this we will be able to find our last and first index of given target. So if we are not able to find the target, then in that case we have to return -1 and -1. Okay, so this is the approach that we have to follow in linear search. So how much time this is going to take? This is going to take big O of n time, and we have to solve this problem in a lesser amount of time. Okay, so how we can solve this problem in lesser amount of time? So for that we have to apply binary search. This is going to take big O of log base 2 n time. Okay, so we will try to solve this problem using log base 2 n time using this binary search approach. So how we can apply binary search in this problem, that is the question. So we have to apply binary search because we know that our array is in sorted form. So for using binary search, we have to first find the index of first occurrence, and once we found out that index of first occurrence has been found, we have to find the index of second occurrence. So let's try to understand this. We have given 5 7 7 8 8 1 0 10. Okay, and target is 8. So first we have to find the index of first occurrence. So we'll do binary search, and so we have to find first. So left is going to be 5 and right is going to be 10 at beginning, and we'll find the mid, that is we do always in binary search. So keep writing the pseudocode for first. Now we have to find only the first occurrence, so we'll be doing this until unless our left is lesser than equal to right, and we have to find the mid is going to be the same method that we apply in all the binary search method, and then we have to check if nums of mid is equal to nums of mid is going, first we have to find 0 1 2 3 4 5. So 0 plus 5 by 2, that means index 2 is going to be our mid. So first we have to check if nums of mid is going to be equal to target. In that case what we have to do, in that case we have to do something and target, and if this is not true, that means in else part this is not equal to target, then we have to go either left or right. So else if nums of mid is lesser than target. So if nums of mid is going to be lesser than target, so in that case we have to go right part. So how you can go to the right, toward right? For going toward right we have to do left equal to mid plus 1. We have to update our left index. So in this case we will be going towards right, and in else part what we have to do, let's say our element, that is current element, is going to be greater than our target, that means 10. So in that case we have to go towards left, so we have to do right equal to mid -1 in this part. And what we have to do in, if we found that our current element is equal to, let's say our current element is this or this, so in this case what we have to do, we have to check if current element is equal to target. So let's say our current element is 8 and we are at index 4. So again, as we found our current element, we don't have to stop checking here. So we have to make sure that this is the first position of this element. So for that we have to keep checking towards left if there is no such element present in left part. So we will be doing right equal to mid minus 1 in that also. Okay, we can see that if we found that our current element is equal to target and we found that current element is greater than target, in both the case with what we are doing, we are moving our search in the left part. So we are doing right equal to mid minus 1 in the both cases. So we can say that we can apply a method something like if nums of mid is going to be greater than or equal to target, then we have to apply this and we can eliminate this else part. Okay, so by doing this we will be able to find our first person. Let's again check and do a dry run whether we are able to find our first person using this method or not. So first L is equal to 0 and right equal to 5, so mid is going to be 2. So we can see that area of mid is going to be lesser than target. So in this case we have to do L equal to mid plus 1. Okay, so L is going to be mid plus 1, that is this, and mid is going to be in this case 3 plus 5 plus by 2, that is 4. So area of mid is going to be 4. Now this is our mid. So we'll check whether our current element is equal to mid. Yes, it is equal to mid. So we have to, what we have to do, we have to go towards left in this case. So R is going to be mid minus 1. So R is going to be mid minus 1, that is this. R is this and left is this in this case. So again we'll found the mid is going to be equal to, mid is going to be, so again left is equal to right and mid is going to be equal to 4 plus 4 by 2, that means 4. So we have to again go towards left. In this case we can see that R is going to be 3. So our, for now R is 3 and L is 4. So we can see that our condition that we had already written, that left is lesser than equal to right, is getting violated. So we'll be out of this loop and the index of L is going to be our target. Sorry, in this case our R is going to be 2 and left is going to be 3. So index of L is going to be our target. That means L is going to be our first occurrence, because at last time our L was present here and we went towards left. So L is going to be our target of first element. That means index of first element has been found, that is our L. So we will store this L is L somewhere, and let's say we are storing index in a variable something like first equal to L. Okay, now we found our first index. Now we have to find our second index. How we can find the second index? We will write code for that here. Now we know that our first element is present here and we have to find the second index. So we know that our second index must be in the right part only. So we have to only keep checking in the right part. So for that our L is going to be as it is, and we have to update our right is going to be n minus 1 in this case. Okay, so this is the left and this is the right. What we can do, keep we can do linear search from here and we can keep checking whether our current element is equal to target. If we found that current element is equal to target, we have to keep checking, and whenever we found that our current element is not equal to target, we have to return the result from there. Okay, so this is the approach that we can apply from here using linear search, but again we will try to solve this only using binary search. So how we can do that? So this is our left and this is our right. Again for binary search we have to do similar method. While left is equal to lesser than equal to right, and first we have to find the mid again, and first we have to check the condition that if nums of mid equal to target. Now we are sure that our nums of mid never going to be lesser than target, so we don't have to check that condition. And so in else part we can say that nums of mid is going to be greater than target. So let's say this is our mid position at a point. So what we have to do in this case, we have to go towards left. So for that in else part we have to do R equal to mid minus 1. Okay, and after that if we found that our nums of mid is equal to target, that means in this case our first mid is going to be 8, so this one. So in this case what we have to do, we have to go towards right. So for going towards right, we have to do L equal to mid plus 1, and now it, we will be able to find our right index by using this. Let's do a dry run and find out the second index. Okay, so this is our L and this is R. So L is 0 1 2 3 and R is 5. So we have to find the mid is going to be 4, that is this one, this element. Now we can see that our nums of mid is going to be equal to target, so we have to do L equal to mid plus 1. So L is going to be mid plus 1, that is 5. So L is 5 and R is 5. Now we have to again find the mid is going to be 5. So we can say that nums of mid is going to be, not in this condition is going to true, so we have to go towards L part, and R is going to be mid minus 1. So we have to update R. So after updating R, R is going to be 4 and L is going to be 5. So in this case we can see that R is getting lesser than our left, so our condition will be get, we will not satisfied in from there, and we will be out of this while loop again. Using now how we can say that we have found our right index. So we can see that when wherever our R is present, that is our right index. So in this case R is going to be 4 and this is going to be second position, that is second equal to R. Now what we have to do, we have to return the first and second, and then we will be able to find our answer. And we found that if we found that our first is not, array of first is not equal to target, in that case from here only we have to return -1 and -1, and we don't have to check this second position. Okay, so this is the pseudocode that we have to follow, and let's go to the compiler and write the code for same. Okay, so first find the length of array, that is going to be nums dot length, and then check if n is going to be equal to 0 or nums of 0 is greater than target, or there can be a condition that means nums of n minus 1, that is last element of array, is lesser than target. In this case we can see that there is no element present in this array which we have to find, so we have to return -1 and -1. So we will be returning from here, in this case new int array of value -1 and -1. Okay, so this was the base condition that we have to check, and then we have to find our result. So for that we have to create a resultant array, that means int result equal to new int of size 2, which will be holding our first and last index. At last we have to return this result. Okay, now we have to create a variable left and right. Left is going to be 0 at beginning and right is going to be n-1 at beginning. Okay, now our first task is to find the first occurrence of target. So we have to keep checking until unless our left is going to be equal, lesser than equal to right, and this will be going to find our first element. And if we found that nums of left is not equal to target, that means no such target is present in this array, so we have to return from here and return new int -1. Okay, and if this is not true, that then we have to update our right result of 0 equal to left, and we have to again assign right equal to n-1, and in second part we have to find the right index. So we will be doing that until unless our left is lesser than equal to right, and after that we have to update our second index, that is result 1 is going to be right, and then we have to return result. Okay, so now we have to update this while loop, and first we have to check the first element, then we have to second the element. So first we have to find the mid is going to be left plus right minus left divided by 2. So we'll be doing this bit manipulation method, and we'll be able to find the mid using this. So first we have to check if nums of mid is going to be equal to target, and this, if this is true, then we have to again go towards right, towards left, and keep checking whether any such element is present in left also. So we'll be doing left using right equal to mid minus 1, and in else part, else if part, if nums of mid is lesser than target, then we have to go towards right. How we can go towards right? We have to do left equal to mid plus 1, and in else part, if our current element is greater than target, then we have to go towards right, towards left. So we have to do right equal to mids minus 1. Okay, you can see that the first and third condition is equal is same, so we can eliminate this condition, and we can write this here. If nums of mid is lesser than, sorry, greater than equal to target, in that case we have to go towards left, that is right equal to mid minus 1, and the second condition will be taken care using else part only, so we don't have to write this condition here. Okay, so we'll be able to find our first index using this. Now we will be updating our first result, then we will be checking the second result, how we can find the second result. So we will be doing mid equal to left plus right minus left divided by 2. Okay, so in this case we have to check if nums of mid is going to be equal to target, then in this case we have to go towards right. Okay, so we have to check whether any such element is present in right or not. So for that we will be doing left equal to mid plus 1. Okay, and in else part, if there will be only two cases, as we have already found the first index, that means no such any element which will be lesser than the target will be present in this subarray. So we have to only check for the equal to target and greater than target. So the second condition will be taken care in else part itself, so we don't have to add the condition here. So what we'll be doing in this part, we will be doing right equal to mid minus 1. We have to go towards left in this condition. Okay, and this will be going to find our second index. So we have implemented both first and second index method for first and second index. Now run this code. Yeah, so our solution has been accepted for given 3 test cases. It's time to submit this. Yes, our solution has been accepted, and this is one of the most optimized approach that we can come up with. I hope you must have learned something from this video. In that case, please make sure to like the video, subscribe to our channel, and don't forget to share this video among your friends. Thank you.